So today I'm doing a math solution of math paper 1, higher level 2023, section B, question 7. So we'll try to work through it now. So Fiona is driving on a motorway. She passes a point A on the motorway. Her speed is given by this equation, where V is her speed in kilometers an hour and T is in minutes. The two units here, you just need to be aware of that and try not get caught up on that fact. And it's T minutes after passing A, this speed is from, where T is between 0 and 5. Work out Fiona's speed when she passes the point A. So she passes the point A when T is equal to 0. So V0 is equal to 2 over 3, 0, 3 minus 6, plus 13, 0, plus 109. That's 109 kilometers an hour. You could tell in the exam that it's 109. You don't need to really write this out. But it always is the best idea to write it out to get your kind of attempt marks. If you maybe write down 108 or something wrong, once you illustrate it, you understand that the equation started when T was equal to 0 and point A is at when T was equal to 0. So now, on to part B. Work out Fiona's acceleration. That is the rate at which her speed is increasing 5 minutes after she passes point A. Give your answer in kilometers per hour per minute. So we want her acceleration. VT gets us speed, but we want her acceleration, so we need the derivative of VT, which is the rate of change of the velocity graph, which is acceleration. So let's try to work that out. So VT, we're going to differentiate with respect to T. So 2 over 3. So we're going to bring down the power and take 1 away from the other power. And we're just going to keep going on this. Plus 13. So that gets us that. We don't really need to simplify it down. You can just chuck in your value. You can just chuck in your value of 5 for T, but I'm going to just do it for the example. You can see that it's a squared graph or a comparison to a cubic. You can see that when you derive something, the graph will change down in a power. So we know the traditional cubic or whatever looks like, or and the squared looks like, and that difference is illustrated in the algebra. So we'll put in 5 into it. So it's the best idea to write this out. Even for just yourself. I remember being in Leaving Cert and thinking I was too good to do that, but I still do it today and make stupid mistakes in exams and stuff like that. Just not writing it out beforehand. And that's our final answer in kilometers per hour per minute. Now, find the value of T at which Fiona reaches her maximum speed during the first 4 minutes after she passes the point A. Give your answer correct to 2 decimals. So what we're going to do here is we're going to equal VT, the derivative of that, to 0 to find the turning points or the stationary points. So 2t squared minus 12t plus 13. So what can we see here? Now, they said give your answer into 2 decimal places. That suggests that there's going to be a decimal in our answer. So I don't think that conventional factorizing is going to be the method for us to find the answer. So we'll use the minus b formula. A, B, and C. Okay, so minus b, so minus 12 plus or minus square root of b squared minus 4ac. This is all over 2a. So chuck that into your calculator and you get 2 answers. We get our answers 4.58 and 1.41. These are the t coordinates or t values of the 2 turning points. So in the question it says find at which Fiona reaches her maximum speed during the first 4 minutes after she passes A. 4.58 is not within the first 4 minutes, so we can kind of chuck that away and kind of ignore it for now and just look at this. 1.141. 1.41 is our time of maximum speed. So just throw in your units there. And other than that, you should be good. Make sure you round to 2 decimal places. Looking at my calculator, I rounded wrong. It should be 1.42. Now moving on to part D. Use integration to work out Fiona's average speed over the 2 minutes after she passes the point A. Over the 5 minutes after she passes the point A. Give your answer correct to 2 decimal places. So what we're going to have to use is the average integral theorem, which is 1 over b minus a integrated of ba. In this case, it's vt dt. Okay, so we've written our formula down. So what we want to do is integrate it between these 2 terms and multiply it by 1 over 5. Okay, so now 50 over 5, 2 over 3, t to the 4 over 4 minus 6 t to the add 1 to the power and bring down the new and divide by the new power. So like 3 over 3 plus 13t squared all over 2 plus 109t. So let's put in 5 first and see what we get. 1 over 5. We can kind of ignore the 0. Looking at it, there's nothing here that will be affected by the 0. So it's 1 over 5 multiplied by... I'm going to try this directly into my calculator. Well, I should write it out. You could simplify this down if you wanted to, if you felt you are at risk of making calculator errors, but I don't, just taking up more time, and especially an exam like this, it is quite time constrained. So I'm going to throw this all into the calculator. So we worked that out to be 86 and a third. Changing to decimals, it's 86.33, 2 decimal places, as in the question, kilometers an hour. Gotta make sure we have our units in the question, in our answer. So now, taking v dash of t to be the derivative of v, and v double dash of t to be the second derivative of t, v dash 1 is greater than 0, and v double dash 1 is less than 0. We're showing the four graphs below, and we have to pick one of them given these conditions. So we got to look at the information we have and through process of elimination, I think, figure it out. So v dash of 1 being greater than 0, what does that mean? That means that the acceleration, that the car is accelerating at the time 1. So we can eliminate all the ones that is decelerating at the time 1. So if we look at this here in graph A, the slope is down, which means it's decelerating, yeah? So we can eliminate that. It's not graph A. Graph B, it's curved up. Even if it does slope off, it's curved up. So it's accelerating. Graph C, it goes down, decelerating. Eliminate that. Now, graph T, it's going up. So we have to look at our second condition because we have to pick between B and D. So v double dash of 1 is less than 0. So what that means is that the acceleration itself is decreasing. So maybe at time 0.5, the acceleration was greater, but it's now at time 1 less than that, and is gonna keep getting less than that till eventually the acceleration is 0 and perhaps it becomes deceleration and the car starts to slow down. It's good to keep a kind of mental image of what's happening when we see these equations. So what it will look like graphically is we'll see the speed here slope off. The slope of the graph will kind of become more shallow as our acceleration decreases. So in graph B, we're accelerating here, and then we can see it begins to decrease and become less and less, and eventually it will become flat and become 0 and start decelerating. So it could be B. We'll just check D just in case. No, in D after time 1, it keeps on accelerating and the acceleration actually gets greater, which means it's accelerating faster and faster, hence the speed going up more and more. Okay, so it's not D, it must be B. What could we write down for our answers? Using v dash of 1, we just gotta explain. Write down which graph this is. Justify your answer using both v1 and v2. Okay. The graph must be what? Increasing. V dash double dash of 1 less than 0. The graph must be decreasing in its slope, in its rate of change of slope. Okay, there's an average speed zone on the motorway, starting at point A and ending at point B. The distance between A and B is 10 kilometers. Cameras record the time taken for each car to travel from point A to point B. Each car's average speed from A to B is then calculated. Work out the minimum time in minutes a driver could get from A to B while not driving over 100 kilometers an hour. So we have to travel the 10 kilometers as short as possible, in the shortest time as possible. So we'd want to travel as fast as possible, but we can't go over 100 kilometers. So we're going to travel at 100 kilometers. So traveling 100 kilometers an hour for the entire stretch, 10 kilometer stretch. Let's work out how long. We want the minimum time in minutes. So let's work out how long it would take to travel. We'll change this unit to minutes, will we? That's my thought on it. So 100 kilometers an hour. Yeah. That means in 1 hour you go 100 kilometers. Yeah. So that means an hour is equivalent to 60 minutes. So what we could do is, to get the speed now in our new units, we go 100, because speed over time, distance over time, 60 is equal to speed. And our new unit is 10 over 6. What would that be? I'm going to go with 5 over 3. And that's kilometers per minute. Yeah. So now we need to figure out how many minutes it would take to do 10 kilometers. What we do there, we're just using our distance triangle of our density triangle of DST. So we have our distance, we have our speed. What we're going to do is distance divided by speed. So distance divided by 5 over 3 will give us the time it will take in minutes. So 10 divided by 5 over 3, 6 minutes. Not shabby. So Rowan drives at the speed from A to B. He passes the point A, driving at a constant speed of 120 kilometers an hour. After 2 minutes driving at this speed, he starts to decelerate at a constant rate until he reaches the point B. Overall, his average speed in driving from A to B is 100 kilometers an hour. So we know that. Let's draw a little line and communicate what we know about this problem. So So 2 minutes. He drives here for 2 minutes in the first part, yeah? How do we say this? So if his average speed is 100 kilometers an hour, it took him 6 minutes to get through the tunnel. So we know this is 4 minutes left over, because the total length has to add up to 6 minutes, because that's what we calculated in the last part of the question. Okay. And we know this red line is 10 kilometers, but it's divided up. It's divided up into the two parts. The parts where he's driving at a constant speed of 120 and parts where he's decelerating. So let's work out the part where he's driving at constant speed. So 120 multiplied by 2, but it's 120 kilometers an hour multiplied by 2 minutes. You can't do that, 2 different units. So we'll put it into hours, 2 over 60, getting us 4 kilometers. And we know left over is 6 kilometers. Yeah, makes sense. Okay. So 4 minutes, 6 kilometers. Let's try to get the average speed there and maybe we can figure something out. If you do 6 kilometers in 4 minutes. So let's multiply 4 by whatever it would take to get to an hour to see how many it is, what our kilometers per hour is. So what you would have to do is multiply by 15 because there's 15 4 minutes in an hour. So we multiply 4 by 15 to get an hour, to get 60, which is an hour, and 6 by 15 is 90. So 90 kilometers an hour. That's his speed in the second part on average. He is accelerating, but on average he is going 90 kilometers an hour. Now this is a bit of maths you probably wouldn't have learned on the course. It's slightly less traditional. So let's draw 2 lines. The blue line is the average speed of 90 kilometers an hour, yeah? So, and the beginning speed is 120 kilometers an hour, yeah? So, the thought is in symmetry. Think of it geometry-wise. 2 triangles here. These 2 triangles have to be of equal size. So that means this has to be, so they started 30 kilometers faster than the average, so they have to finish 30 kilometers slower. Yeah, does that make sense? So that means they finished at 60 kilometers an hour. Okay, to work out the deceleration, to go from 120 to 60 in 4 minutes and 6 kilometers. Yeah. The deceleration is in kilometers per hour per minute. So let's think about that. Not too bad. There's a 60 kilometer difference here. 60 kilometers between this, between the 120 and the 60. So it gets pretty simple. 60 kilometers divided by 4, because it's over 4 minutes, gets us 15 kilometers an hour per minute. And that's our final answer. Bit of tricky maths in that question. So yeah, that's our final answer there, as deceptive as it is. Well guys, thanks for listening. I have maths coins available. If you're interested, just click the link below. Thank you.